afternoon, everybody. So my name is Philippe Delfosse. I'm the advisor for the Vice Rector for Research at the university. My background is in agronomy. I was specialized in animal nutrition and then shifted to plant virology. So you see, I'm already quite interdisciplinary in my research approach. And all my career, that's what I try to do. To move slides from slides, can I use this? Today I have the difficult task to take over the talk of Jens Kreisel, the Vice Rector for Research. The second one is to keep you awake during your digestion process. So please bear with me. Stay behind it or? Up? So I'm using the slides of the Vice Rector for Research, and I added my personal touch to it. I know it's moving too fast. I didn't ask for this. I wanted to say something about, is there a direction where to put the pointer at? Nobody knows? Okay. If you want to be excellent in research, you need excellent people and excellent infrastructure. But you need this binomial, it's very essential. In the context of digitalization and development of high-performance computing, the European project of the Euro HPC was very, I would say, convincing to push Luxembourg to also develop its own platform and to be an actor in developing this Euro HPC. And the context in Luxembourg is quite favorable. We have the digital line and the optic fiber almost all over the country. We have at least the Meluxina platform, but also now in the university, we have the new ION HPC. So a very strong infrastructure and very up-to-date infrastructure to promote collaboration around data science, machine learning, artificial intelligence. During our exercise to develop the digital strategy for the university, we have gathered a number of researchers and professors of the university, and we came up with 4 main axes, developing digital literacy with a new diploma and curricula, but also a center for digital ethics. In the digital administration, we are currently working on a very important tool, which is a current research information system that centralizes all the information related to our research projects. And regarding digital research, the structure that I just mentioned, the HPC platform. And when we did this exercise, we found out more than 50% of the research project at the university have a digital component. So that's quite important to keep in mind. Recently, when we developed the strategy framework for up to 2039, we developed 3 key strategy axes around medicine and health. You see digital transformation again. And then the new axis, which is sustainable and societal development, something that was really lacking. And when we had the event of end of the year with the rector in 2018, there were many professors asking for involvement into study for climate change, societal challenges, migration, food supply, and all those things. And we are quite poor till now in sustainability. The reflection of the Vice Rector to develop a strong structure for data science, high-performance computing, integrates both the infrastructure, but the researchers that are involved in data science, and then the approach using machine learning or artificial intelligence. And combining all these aspects, all those 3 components, is very essential to develop not only the infrastructure, but also the people that will use this infrastructure. so education and training. So combining those different components, we hope to develop a very strong asset for the university to further develop collaboration within the different, often called silos, different departments, faculties, ICs, but also with society and the industry, offering high-performance computing to the industry to collaborate with us. And what you can see also is that the digitalization was also a very strong mean to stimulate collaboration between the different departments. And one of the first requests from professors when Jens Kreisel joined university was to promote interdisciplinarity, to break the walls between the departments. Universities are often structured in a very nice way, but we need to break those structures so that people are working together. And this is the result of the Institute for Advanced Studies, and you see the project that were initiated from 2019 till now. And you see it's very versatile, and it's across the full university. Almost every department, each department is involved in those collaborative projects, and all of them are interdisciplinary. This is a very crucial condition to be accepted in the Institute for Advanced Studies. And personally, I found the last call, the Young Academics 2021, so refreshing. We had young people just holding a master, applying for a PhD position. And those young people are just amazing. They are just so mature in their reflection, in their development of project proposal. This was a very refreshing time for me. And also for my Vice Director for Research. To illustrate some of the projects that are run, and those are actually the 4 pilot projects that initiate the movement in the Institute for Advanced Studies. The first one with Marc Cole and Yves Le Traon are combining artificial intelligence and the legal aspect and the decision in court. The second one is integrating Anja Leist, Paul Wilmers, and Heiko Krüger, looking at the socioeconomic status on the gut microbiome of the people and the risk for dementia. You see how spread it is. The third one with Conchita D'Ambrosio and Alexander Kachenko look at data science economics for well-being. So they use a very large database of economic origin, and Alexander is using a very complex computational approach to link this with well-being. The last one finally is bound to history, and you have an historian, Andreas Ficker, a chemist, environmental chemist, Emma Szymanski, and an hydrologist, Laurent Pfister, working all together to look at how the history has impact, how the environment was impact over history, and how this can affect health today. The need in terms of computer performance or power is very different according to the discipline that is using this computer. And this is just to illustrate that according to the discipline, you need either very high-speed computing, or you need high storage, or you need high-performance communication between the cores and your final computer. So very specific needs. But generally, you see, we need everything. As a university, we need everything, and there's a need to develop a very strong platform. This is to symbolize that for the university, this core platform is very demanded, but also very needed. We also have to keep in mind that access to HPC might be very complicated at first sight. I mean, it's a big machine, it's very prestigious, so we need to train people how to use those HPC. And there's a strong need for teaching, learning, and there's a good opportunity for partnership. So also in the future, this platform will help to explore emerging technologies, but also shifting to quantum computing. Now I'm again coming back to a quick personal touch. My last expertise was in biogas. And why do I want to talk about biogas? It's because it's a very complex yet natural process. And you have so many microbes there that are not described. We don't know what they do. We don't know what they are. And just to illustrate how we explore this very complex system is that we use high throughput sequencing, and you see how many, let's say, species we discovered in this system. So each line is a species or a sequence at least. And because we cannot culture those organisms, we wanted to characterize them in some way. So we looked at their genome characteristic, but high throughput sequencing can only deliver small sequences. And then you need to reassemble those sequences. But when they are so numerous, you don't know how to patch them together. It's which one you will take to accommodate the other. It's very complex. So what we did, we look at environmental data. That's for you, it's the left side of the graphic. And just to illustrate it in a more simple way, we just look at what finally end up to be 2 microorganisms. We look at how those sequences are evolving in the different environment. And if they are a parallel evolution, then we could suspect that they were related to the same organism. And then all those sequences were put in a bin to reconstruct the genome. So this is just an illustration, and you cannot achieve this without people. The key definition to interdisciplinarity is the people. If you have a very good computer scientist, Bertian Bruxema on the right side, and a team of microbiologists, engineers, and agronomy to work together, to spend time to learn the language of the other one. It takes time, 6 months for us to understand each other. We use the same language, English, but yet English for a computer scientist is not English for a microbiologist. Those are 2 different worlds. And you need to reconcile those 2 worlds to be able to work together. So a lot of time to invest to just understand each other, and then to make a nice team to start working together to eventually deliver something that is very useful. So my message is really this: spend time, take time, be patient, listen to the other, and also explain in very simple word what you wanted to do. Thank you for your attention.
Thank you so much, Philippe. Always a man full of good sense and good, insightful thoughts.